Hey everyone, we're going to start off this unit by kind of having a little bit of a quick review on vectors and then kind of expanding on it a little bit as we go through the unit. So our first section is really how vectors can be applied in different scenarios and different situations. So as a quick review, we have dealt with vectors in the past. Vector quantities, they have both a magnitude and a direction. Now, basically when we say stuff like have a magnitude, really what we're trying to say here is that they have a number associated with them, and specifically magnitude refers to an absolute value, so it's a positive number. So it would be something like saying going, say, 50 kilometers per hour, and then they also have a direction like saying going north. So we can kind of make that connection that magnitude and a direction imply making a vector. Now, notice I had mentioned earlier about being an absolute value or positive value. If we have a negative here, remember the negative really just indicates the direction. So a negative in our cases really are going to indicate south or west. So some examples of vector quantities are things like velocity, like we talked about in the past, force measured in newtons, and acceleration in meters per second squared. And then this one, momentum, is something that we'll actually get into a little bit coming up. So vectors are represented by arrows, and normally when we see our arrow leads somewhere, right? So wherever our tip of our arrow points, that's the direction it's heading in. In this example, it is heading in the east direction. Now that's the difference compared to a magnitude, because a magnitude has arrows on both sides. So magnitudes are just saying that this thing is, say, 50 kilometers per hour, right? It's just giving the idea of a velocity. Whereas this one is saying specifically 50 kilometers per hour and then specifically heading east. Okay, so just the idea of what a vector is. Now, graphically, we can add vectors together, and there's a couple of different methods that we're going to go through. So the first one is called the tip-to-tail method, and this is actually what was used in the past, maybe when vectors were introduced. We could draw any line, so let's say we have line A and line B, or vector A and vector B. And then we have the purple line here that's going to be our answer. Now our answer, oftentimes, we're going to see this R that's here, and R really just stands for resultant. Okay, it's the answer. Okay, so the resultant of the value. Anytime we have a vector, remember, it has an arrow on top of it, that indicates that it is a vector. So here we have vector A and vector B, and then we can figure out its resultant if we go from the start right to the end, and the arrows tell us the directions that we're heading in. So A is heading east and B is heading at some angle relative to the plane. At the end, if you maybe remember this stuff from before, normally we have to say the answer in terms of the direction where it's heading. So we'd have a line here that we could measure, and we would say, okay, we know that this is 10 kilometers long. But we also have to reference it with an angle and say it's 10 kilometers long, but it's also 25 degrees, north of east. Okay, something along that line. So the angle always shows up from the beginning where we start. Okay, it always measures the angle from the starting point. And that's really important as we kind of move forward. The other method is the parallelogram method. It's very similar, and we're going to practice this a little bit as well. So in our parallelogram method, what we do is we have our two lines, and instead of drawing them tip to tail, like we do up here where the next line starts where the first one ends, in this case they both start at the same beginning, and they both go out from there. So after that, then I use this idea of building a parallelogram. Whatever I have for A right here, well, this is also A up here. Whatever I have for B over here, it's also B over here. Okay, it's the same line matched up again, same degree measure, and then they come to a point, and then all I do is I take my starting point and connect it to my end point. Okay, and then this line is my resultant line, and then I can go back and measure theta just like we would have before. We can also have, similar to having positive vectors, we can have negative vectors as well, and just kind of keep in mind that really directions here are going to imply where these things are heading. So I could have, say, vector A, and then understand that if I took vector A and I just put the arrow in the opposite direction, well then I have negative A, right? It's heading in the opposite direction. Remember that we can also draw vectors to scale. So if this is the length of one vector, the length of A, then two of them, right, one over the other, is going to be negative 2A. It's heading in the opposite direction, and it's twice the length. So I can use vectors to really kind of describe a lot of different things, and hopefully that's okay for kind of a refresh to be able to move forward. So the two methods of solving vector problems, we have this parallelogram method that we talked about. That's the one that we're going to start with. And step by step below is how we go through it. I'd encourage you to kind of take notes along the way just to kind of fill in any of the gaps or anything that we have, and hopefully be able to understand how to go through and draw the parallelogram method. So the parallelogram method uses geometry, and it does use a little bit of advanced trig if we were to solve it mathematically, like law of sines and cosines. So we have our step 1, we have our vectors. Step 2, we put our vectors together and basically combine their starting points. Step 3, we make it into a parallelogram, where if this was B down here, then this is B over here, and if this was A, then this is my line A just mirrored off the other side. So it's kind of like two tip to tails. Then I take my starting point and connect it to my end point where it goes. I have my resultant line, and we would say that this is the addition of vectors A plus B. So lines should be drawn roughly to scale as close as you can to get an accurate description of the magnitude and the direction of that resultant line. So a couple of examples that we're going to run through. It says use the parallelogram method to then find the resultant of a 1.6 kilometer east line, so something that's going 1.6 kilometers east, and then it's going 3.4 kilometers, 35 degrees north of east. And we have to use the parallelogram method to find out what this resultant line is going to look like. So I have taken the liberty of sketching out a couple of lines, and I'll just kind of show you how those lines are measured out. So if we take our first one, okay, so our first line, if I were to take that and just kind of show you the measurement for it, I can see here that I got it as close as I could, right to the end, to get it to go roughly to 1.6 kilometers. Okay, so resultant line 1.6 kilometers east. So I took my ruler and I measured a line 1.6 kilometers east. Okay, that was my beginning part, my first point. After that, then I had to use the protractor to measure out what 35 degrees was. So I took my protractor, I put my crosshairs right at the origin point, and then I measured out what 35 degrees would look like right there. After that, once I knew where 35 degrees were, then I had to make sure that I measured that line coming off here and had to try to measure it out to be 3.4 kilometers. So I got it as close as I could to match that up to be 3.4 kilometers long. So as you can see, I have my two lines kind of already drawn out. So from there, now I need to turn this into that parallelogram shape. Now it doesn't matter in terms of where the lines necessarily go right off, but because the parallelogram method, remember, they both start from the same starting point. So I'm just going to match up my green line at the same origin point as my blue line. Now, in terms of the parallelogram method, I need this green line to show up here again, right? I need to make a parallelogram out of this, and I need my blue line right here to show up on the opposite side to make that tip to tail shape again. So I'm going to start with my green line. Okay, my 1.6 kilometer line. I'm just going to copy it, and I'm going to put it tip to tail over here. Then I'm going to take my blue line, I'm going to keep the same angle, and I'm going to bring it down so it makes a parallelogram down on this side. Now, what I can see is that I've got this parallelogram shape. So the next thing I need to do is I need to draw a line that can connect my start point to my end point. So I'm going to start from my beginning point, and I'm going to go clear over to my end point. Now that is my resultant line. That's my line that I need to measure and find out what this angle is as well. So I need to measure and find out how long it is. Okay, so I'm going to take my ruler, we're going to measure it out, and just get it as close as I can here to try to get a good measurement. Okay, and it looks like I'm getting somewhere in the neighborhood of about 4.9, okay, 5, somewhere in that neighborhood. So putting this roughly to scale, we can also say, so I can also kind of use a scale here and say that for every kilometer, so every 1 kilometer, I basically have a centimeter. So if I have something that was 4.9 centimeters, that means I've got something that's roughly 4.9 kilometers long. Now, in terms of measuring and accuracy, I really should go 1 digit further with this, so I'd say like 4.90, because we always go 1 digit past whatever the smallest measurement is in our measuring device. So I'd say our next thing now would be to take my protractor. I'd set this up on my starting point, and I'm going to try to measure what this angle looks like. So this angle looks like it's about 24 degrees where I'm starting. Right, starting at 0 on the inside, looking out, and I look at here, it looks like it's about 24 degrees. My direction off of this is that it's going north of the east direction. Okay, so roughly 24 degrees north of east would be my my estimate for the angle. So it looks like my resultant line measures out to be about 4.90 kilometers long, and it looks like it's about 24 degrees going north of east. Okay, now I can check that and see how close I am based on my accuracy, based on measuring it, and it looks like 4.8 and 24 degrees north of east, so really, really close. Okay, and again, just kind of being, cautious or careful with your measurements and making sure that you're able to measure this as accurately as possible. Okay, so parallelogram method, just a matter of using a ruler and a protractor.